Hello, in this video we're going to look at how to reverse byte order, and it's something which crops up in the Bitcoin core code. So although that's written in C++, we will look at how we can reverse byte order using Rust. Okay, so reverse byte order, we're going to look at the code that reverses the reversing, if that makes sense. And this is the original code which reverses the byte order. It's in C++. So let's look at how we reverse or undo this, and then we will look at the concept behind it. Okay, so if you want the too long don't watch, this is the actual result of the code and the code itself. So what we've got is a input, which is a transaction ID, and we want to reverse that. So string, we reverse the order of each byte. Now each byte is 2 hex characters. So we convert it to bytes. You don't have to convert to bytes, you can do chars as well. Then we use chunks. So I'd not used chunks before, so that's a good thing to learn. Then we reverse it, which is what you would expect. And then we do flat map and map. So map is to convert the bytes back to characters, and collect to string is obviously just to convert back to string so that we can print it at the end. The flat map is a bit more interesting, and that takes you some getting your head around. Let's also look at the reason behind all of this. So the order behavior is probably an unintentional consequence of a design decision in early Bitcoin software. As a practical matter, even, it means developers of Bitcoin software need to remember to reverse the order of bytes in transaction and block identifiers they show to users. You can see there's quite a terse bash example here, which is using fold-w2 tac, which is cat backwards, and then tr-d. Okay, so this is actually a stripped down example, and it's not actually doing the full reversing of the byte order that we just saw, but this is actually start of the concept. And what it's doing is it's breaking the string into chunks of 2, and then it's doing something with alternate chunks, which is kind of the starting point, or kind of a good building block for what we're actually going to be doing. So with index over chunk size modulo 2. So that's actually giving us it's rounding down because we're not specifying the chunk size as a float. It's actually rounding down. And the whole beauty of that is because it will round down a fraction. So 1 over 2, it will round down to 0. It takes a bit of getting your head around, but it does the job. So if you're familiar with Python, you've probably come across the double forward slashes and the single forward slash. So this is equivalent to the single forward slash because we are not using decimal places. So 1 over 2, which is 0.5, will get rounded down to 0. Then you do 0 modulo 2 equals 0. So when we run it, let's just save it. You can see what's going on under the bonnet. So index 0, we're using, just go back to the main screen. We're using enumerate here as well, so that's really important or crucial to the whole way it works. Index 0, index over chunk size modulo 2 is giving us 0, 0. Then when we go up to 2 and 3, so index is 2, chunk size is 2, so 2 over 2 is 1, 1 modulo 2 gives you 1. 3, so 3 over 2 is 1.5, 1.5 modulo 2, or 1.5 rounded down would be 1, 1 modulo 2 gives you 1 again. 4, so we're going up again, this is to give us our alternating sequence. So 4 over 2 gives us 2, 2 modulo 2 gives you 0. So you can see that's a very neat trick. And AB, so it'll print AB, and then it just substitutes dots when we've got remainder of 1, and we've got a remainder of 0. It goes back and it prints the characters again. So this is the start of what we looked at with the reverse byte order. If you want to see the full reverse byte order code and the article, then I'll put the link to it below, and I've put it on my website. But here, this is probably the important bit to kind of grasp, which is where you're using a division of an integer or a U size even. So you're not getting a decimal point, you're just getting rounded down. So again, as always, best thing to do is to copy the code or copy the code, edit the code, break the code. We're using a vector here to store the results. So we're pushing the character value onto the vector mutable. That's if modulo 2 equals 0. Otherwise, if modulo 2 is an odd number, then we just push full stop onto the vector. And then obviously up here, we just call our function. We pass in the input string, which is this. We pass in the chunk size. In fact, let's just change that. So let's go for 3. Let's run it. And you can see ABC ... GHI ... So even if you don't memorize this code, just remember that there is a neat trick that you can do using modulo and using division of integers because they get rounded down. I hope I've explained that well. If I haven't, I apologize. I'm still learning Rust. That's why the channel's called Learning Rust. If you like this, or if it's given you some food for thought, or you would suggest a better way, then please drop me a comment in the comments. And once again, thank you for watching.